His answer was, the engineering authorities or the technical authorities within the company are responsible for major hazards. The problem with that answer is that process safety, major hazard safety, is more than engineering. Of course, the engineering authorities are responsible for ensuring that engineering designs are good designs, that the engineering is quality engineering. But there is more to process safety than engineering. There is also the behaviour of the people who are managing those major hazards. Major hazard safety depends upon the frontline operators complying with the procedures which are designed to control those major hazards. This is not the responsibility of the engineering authorities or the technical authorities. There was nobody in BP with a particular responsibility for that. The behaviour of operators in relation to major hazards was uncontrolled and unaudited and not subject to any kind of scrutiny. In other words, there was no behavioural safety focus on major hazard risk. BP had good behavioural safety programs in relation to personal safety. What they needed to do was to realise that behavioural safety programs are relevant for major hazards too and must be applied to major hazards as well as to conventional hazards. This was a huge gap in BP's approach to safety. They were not looking at the behaviour of people which is relevant to major accidents. So it was that there was no scrutiny of what the people doing the well integrity test were actually doing. No independent verification that they knew what they were doing or that they were complying with relevant procedures in carrying out that test. There was just a general assumption that they could be left to themselves. The final barrier failure I want to talk about in this program was the failure to monitor the well in the last stages of the operation. The rig was connected to the well on the sea floor by what was called a riser. The riser was full of drilling fluid, mud, which is twice the density of seawater. Before the rig departed, the riser had to be removed, and to do that, the crew needed to replace the mud in the riser with seawater. That is, they had to pump seawater into the riser and mud out of the riser. A blowout can occur during this operation if the cement is not properly sealed, so it was vital that the crew monitor what was happening. The principle of monitoring is simple. If things are going as planned, then the volume of fluid going into the riser will be matched by the volume coming out. If more is coming out than is going in, you know that the well is not sealed, and oil and gas must be coming in at the bottom. It's as simple as that. To monitor the flows, the fluids that are going into the well are taken from one tank and the fluids coming out of the well go into another tank. You can watch the levels in these tanks rising and falling to ensure that the volumes are in balance. That is what monitoring means. You watch the process. But in the last stages, the crew was not doing that. They were taking the mud flowing out of the well and directing it straight overboard into a supply vessel, bypassing the volume measuring tank. In other words, they were not monitoring what was coming out of the well. This was a very major monitoring failure. They were doing this because they were trying to do a number of things at the same time. These simultaneous operations contributed to the failure to monitor the well. Why were they rushing in this way? They were under enormous cost pressures. They were many days overdue, millions of dollars over budget, and they wanted to finish as quickly as possible. Another factor contributing to the failure to monitor was the lack of any behavioural safety focus on major hazards. As we saw, this factor also contributed to the failure of the reduced pressure test. In this final stage of replacing the mud in the riser with seawater, the procedures they were following were not the procedures they were supposed to be following. BP had no system for checking if the people were following the correct procedures in relation to major hazards. The reason was, as before, that safety for them was all about occupational safety and not about process safety. Another part of the story is the failure to learn from other incidents. There was a very significant previous incident on a Transocean drilling rig 4 months earlier off the UK coast. They had finished drilling the well, They had cemented the bottom of the well, they had conducted a reduced pressure test, they had declared the well was safe, and they stopped monitoring the well. Then the well blew out. But fortunately, the blowout preventer on the seafloor was activated and the blowout was stopped. This was sheer good luck, not good management. Had the blowout preventer not worked, it would have been a disastrous event, possibly as bad as the Macondo disaster. Transocean was very upset and disturbed by this event and sent out circulars to its drilling crews saying, "Do not be complacent. You must go on monitoring the well until the very end. Do not give up on monitoring your wells." But nobody in the Gulf of Mexico received these circulars. Nobody knew about the blowout in the UK waters. So there was a complete failure to learn from a very similar event within the same company. It points to a serious failure in Transocean's capacity to learn lessons. Remember too that the executives who did the walk around on the Deepwater Horizon saw themselves as transferring lessons from one rig to another. The lessons they were transferring were about personal safety, not about process safety. If they had thought about transferring this lesson about the need to maintain vigilance until the last minute, they would certainly have realised that the drillers on the Deepwater Horizon were not monitoring the well in the final stages. Here again, the emphasis on personal safety led them astray. Finally, let me ask some questions that will help to summarise some of what I've been saying. The general question is this: why did this incident occur when and where it did? Let me break this down into more specific questions. First, why did the accident occur in the drilling operations in the Gulf of Mexico and not in the production operations? I suggest this was because the indicator of major hazard risk they were using was loss of primary containment, which is relevant to production but not to drilling. The indicator they were using, and it was in the performance agreements, was helping them to focus on the major hazard risks of production, but it was not helping them to focus on the major hazard risks of drilling. Second, let's think for a moment about the difference between exploration drilling and development drilling. Exploration drilling involves drilling in new areas. Geologists will have made predictions about where oil and gas may be, and the next step is to drill exploratory wells to see if they are right. Once you've discovered where the oil and gas is, you drill development wells to open up the field. Macondo was an exploration well. In other words, the blowout occurred in the exploration drilling group, not the development drilling groups. Why was this? I suggest that the answer is that this was the only drilling operation in the Gulf of Mexico that remained decentralized, that is, where engineers reported in at the lowest level. Finally, why did the accident happen after drilling had been completed? The answer is because this is the most dangerous time. When people believe that the job is done, when they think that the job has been a success, there is a tendency for everybody to drop their guard. It's really important that we understand the human and organisational causes discussed in this program, because these are the things that we must get right in order to prevent such accidents from happening again.